Dr. Memari, one more time, experiment 10 for current 1045 lab. Our experiment for today is molecular weight of volatile liquid using gas laws. We are using actually ideal gas law. That's PV equals nRT. We are trying to find number of moles of the gas from collecting experimental values for pressure, temperature, volume of and R of course is universal gas constant. So that's what we are trying to do here. We are trying to, and then the mass of the gas or number of moles of the gas, mass of the gas that is we can collect. So I'm just going to start with the procedure and what do you need to record in your data sheet. The data sheets are provided in a Word document. They are editable. You are going to add. Make sure, as again a reminder one more time, that you need to download this before you start watching the video, and as you watch the video you record the numbers. First thing first, the unknown that I'm going to use today is unknown B. There are three choices of unknown A, B, and C. I'm going to use unknown B, so we record that unknown here as the unknown B. Then we are going to measure mass of a flask. So overview of this experiment, I'm going to pour liquid into the flask, heat it up in a hot water bath to vaporize, change it to gas, and that's the gas that I'm studying. So I want to measure the mass of the gas that is going to be in this flask. So I have to measure empty flask first. And I'm going to, since I don't want to open it later, so I'm going to seal it first and then measure everything together. The procedure, it does explain that also. I'm going to drop in a couple of the boiling chips. This is going to help me to identify if all liquid has been evaporated or not, because then the boiling chips is going to come out of the liquid and it would be exposed, so it's easier to see. That's the only purpose for it. And I'm boiling liquid in there. It's a small amount of liquid. I'm using aluminum foil to cover this. The aluminum foil is going to protect it. First time around, I would try not to make it too tight, because you see that I'm going to open this before adding the liquid. So I'm just going to, the whole point is to have the mass. I make a pinhole on the aluminum foil, and the purpose of that is to make sure the containers open to the space in this lab area. Why I'm doing that? Because then making assumption the pressure inside the flask is equal to pressure that is in this lab area. So let's go ahead and measure the mass of this. Total mass for flask, foil, cap, the rubber band, and everything I have. I'm going to record this number, and you record that number for the first and second trial, because we are going to use the same container for the second trial as well. So 960. Then, based on the procedure, I'm going to open this and transfer. So carefully open. We don't want to tear the aluminum foil, because if I replace this aluminum foil, it's going to have a new mass, and it's not going to be accurate. I'm going to add 5 milliliters of the unknown liquid that I have here. The amount of this, or exact volume, exact mass in the liquid form, is not crucial. So I'm going to use a graduate cylinder and measure 5 milliliters of the liquid. Okay. You can always adjust the last drops using a dropper, but looks fine. Meniscus is at 5. I'm transferring that to the flask and cover it. Going to cover with the aluminum foil and use a rubber band to secure the aluminum foil. Okay, I'm going to fold these pieces up The reason for that is because I'm putting this in the hot water, I don't want any water to trap underneath the aluminum. So I take this and I place in a hot water bath. The hot water bath is set up using Bunsen burner, and then the beaker, large beaker. Why I'm using large beaker, I want to make sure that the flask fits in. The procedure says like 1/3. 1/3 of this, or half of it, as long as this portion of the flask that has liquid is immersed, is inside the hot water, it should be fine. So I'm using a utility clamp to secure it. Often, students, they put the utility clamp in different directions. For me, because I'm right-handed, to be able to adjust this and on a screw or a screw is easier with my right hand, I place it in a way that the screw is to my right. So I would connect it and secure with the utility clamp. So after I secure this with the utility clamp, I'm going to lower that utility clamp low enough to get my flask inside the solution. Okay, we don't want to put too much water, so make sure it's no more than half, because when it starts boiling, it's going to splash. You don't want hot water splashing and boiling off the container here. We are using a thermometer. We are going to use this digital thermometer to measure the temperature of the water, or the boiling water. I want to make sure the flask stays in the water long enough for temperature inside the flask to reach temperature outside of the flask, or temperature of the water. Because I have another assumption here. My assumption is that the temperature of the gas equals temperature of the water. So if I just drop it and remove it, it's not going to reach the same temperature. So I'm going to make sure wait until the liquid evaporates completely. And when the liquid evaporates completely, I want to make sure that it stays there for at least like 5 minutes for the temperature to reach the temperature of the boiling water. So the boiling water temperature, that's another story here. It can be assumed 100, but it's not always 100. It depends on the water that is used. It depends on the pressure that is in this room. The boiling point, it could be different than 100, but in this case, it's just recording 100, and I'm happy with it. It could be 101, it could be 2. And again, if I lower this probe, the temperature probe, all the way down where the flame is touching directly the probe, the flame is touching directly the beaker, it can actually show higher, and that's false. So I'm going to float it where the gas is. Okay, hold it up and record the temperature, and we are not going to change this number. Whatever it shows, that's what we are using here. So it records here 101, and that's the temperature I'm going to use, 101. Remember, for gas laws, we can't use degrees Celsius, and you want to change that to Kelvin. So we are adding 273.15 to that temperature to change it to Kelvin. Okay, want to make sure the solution has evaporated, the liquid has evaporated, all the liquid is gone, and there is really no liquid left there. Then I'm going to remove it from the hot water, let it cool down. Okay, you could see sometimes the stream of the vapor coming out of the flask through that pinhole. That's the excess of the vapor. So it's going to capture or just fill up this flask with the vapor from that liquid, and that is the assumption that we have. So we are taking how much gas we are using. The amount of the gas equals to the volume of this flask, because when the liquid vaporizes, it's going to first push up the air out of the flask, and it fills the flask with the gas or the vapor from that liquid. So check it one more time. Okay, perfect. There is no liquid, and when I take it out, I'm going to see condensation. Of course, that condensation that is coming from the vapor now at the lower temperature back to liquid, it's okay. That is condensation, is not the liquid that was not vaporized. I'm going to leave it to go to the room temperature, and I measure the mass. Before measuring the mass, I always remind the students, make sure to dry the outside of the flask, because if we have water outside of the flask, it's going to add to the mass of the mass of the gas, and that's not what we are measuring. We are just measuring mass of the gas. So I take this to the scale now, and I measure the mass of flask. We'll make sure it's okay. Very good. And measure the mass again. This is the mass of the vapor or condensed liquid plus the flask and everything else. That's 96.455 for me, and that's only for this trial 1. And I record that number. I'm done with the trial 1 of this experiment. For the second trial, the procedure is asking me to add, don't change anything, okay? We are using the same setup. The flask is the same, the rubber band is the same, aluminum foil is the same. We open all these carefully without tearing the aluminum foil. That's why I want to be very careful with this. And we are going to add 3 milliliter extra of the liquid to the flask, and do this experiment one more time. Evaporate the liquid and measure the mass. So 3 milliliters, adjust with the dropper, the last drops if needed, to get the meniscus level with the 3. Transfer, cover with the aluminum foil, secure with the rubber band. Okay. Hold the foil up so it doesn't trap liquid. Use a utility clamp to secure it, because that area is hot. You're doing on the bench. I'm secured with and I use this as kind of handle. Now place it back in hot water. Let it evaporate again. So we wait for it to evaporate one more time. We do this to trial because every time you do measurement, there is some error, experimental error. The hope is that one has extra, like positive error, the other one negative error, it cancels. Or if the numbers are way off, that means something went wrong during one of the trials and you need to repeat the experiment. That's like in general why we are doing more than one trial. When we are making any measurements or collecting data, it's better to do more than one trial. So we need the temperature, which is the temperature of boiling water. We need volume, which is the volume of this flask. And I show you how to measure the volume of the flask quickly after we measure the temperature and the mass. We also are going to measure the pressure. How do we measure the pressure? If you remember, just a few minutes back, I said we make the pinhole here. We open this gas to the room. So if there is extra vapor in there, it will exit until the pressure inside and outside is going to be the same. So we are using a barometer to measure the pressure and the pressure of this room is equal to the pressure of the vapor inside the flask. Of course, we are making assumption. It could be like a little bit high or low, but it has given good result, and that's all we can do at this point, really. So the liquid has been vaporized. I can see the stone. I could see the boiling stone. That's how I know the liquid has been vaporized. And I want to make sure the temperature is equilibrated for the gas inside and out. That's why I left it there for 3 to 5 minutes. The liquid is vaporized. I'm going to repeat proper technique as I did before. Dry the outside of the flask. I didn't measure the mass with the utility clamp, so I need to separate that. So wait for temperature to reach room temperature. If there is any water trap underneath the foil, we can wipe it out, dry it, and measure the mass one more time. Record the mass, 96 for okay. I wait for it to reach 96 509. And we recorded the mass. We are done with this part of the experiment for the mass, measuring of the mass. Now, I promised that I'm going to show you how to measure the volume. To measure the volume of the flask, it says 125 here, but that what 125 is up to this mark here, 125. There's nothing to stop the gas going up, so basically we have to measure the volume for the full flask, and one of the ways to measure that is going to be measure how much water this flask can hold. So what I'm going to do, I'm going to fill it up with water and get the stone out, boiling stone. Measure, fill it up to the rim, all the way to the top. I usually do this part of the experiment next to the sink, so there is no water splash at my station. But for recording purpose, I am trying to be very careful, and I do that here, okay? But I am very careful. So I filled up all the way as far as the gas could go up, then measure how much water this flask can hold. How much water this flask can hold, it's going to translate to the volume of the flask. So I measure to 100 first. So that's my 100. Okay. I can use larger graduate cylinder, or I can empty the 100 milliliter, pour the rest of the remaining of the water into the same graduate cylinder, record this number. This number, it's again the meniscus, or the level of the liquid in the graduate cylinder. It's between, I'm gonna hold it for you to record it yourself, with maybe a background, white background, just to give you a little bit of work to do. So you can, or a dark background, whichever is going to help you better with different background. So you see that the meniscus, it's between 60, is between 61 and 62 for me. and it can't be very accurate. It's almost halfway, so I'm going to record that volume as the 100 plus 61.5. That would be my number. That's the volume in milliliter. Of course, for the gas law or the ideal gas law, the volume needs to be recorded in liter or converted to liter. That's your job to do it. So I'm just your lab partner. I'm performing the experiment. You can do the rest of the experiment. So now what we are missing is the pressure. Let's go to the barometer and measure the pressure.